Good morning, everybody. It's my pleasure to introduce this morning Kent Taylor, who is a volunteer with the Climate Reality Project. Welcome, Kent, here to the North Shore Senior Center and to the Men's Club. And Kent's topic today is going to be global warming, a man-made problem or myth. And he's going to explore whether human activity is responsible for global warming, or is it something else? Kent has a very impressive resume, and I just want to give you a little bit about it. He was born in Evanston and raised in Glenview, right down the road. He graduated from New Trier High School in 1967, went on to Michigan State University, where he earned both a bachelor's and a master's degree. And while at Michigan State University, he took many courses, became very interested in the environment. He also became a certified scuba diver and water safety instructor. And with that background, he, in addition to his consulting business that he was engaged in, he was a diver presenter at the Shedd Aquarium in Chicago for more than 20 years. And you may have seen Kent there if you brought your grandchildren to the Shedd Aquarium. One of the things that he specialized in was coral reef ecology. He lectured weekly, and he brought focus to the adverse effects global warming was having on the coral. And this is based on his own firsthand observation of reef deterioration in the Caribbean. One of the things about Kent is that because of his great service at the Shedd Aquarium as a volunteer, he was named a volunteer emeritus of the Shedd Aquarium, only one of 4 to get such an honor. So let's welcome to the podium Kent Taylor.
Everybody hear me? Does that work well? Good. All right, well, Don, thank you very much for that lovely introduction. Read it just like I wrote it. Appreciate that. I'm going to try to move this a little bit to give me a better angle on my own screen here. Hope I don't disconnect all the things that they've been working so hard to connect here. I think I succeeded. I was told by Don Packard, who was at a debate that I had with a very well-published person on the opposite side of my argument. They call them skeptics or deniers, any number of different terms. Written 3 books on the subject. And we'd had a debate, and Don saw it about this topic and said, let's bring this topic to you guys. And I said, well, debate was kind of, rough and tumble. I get a little political, I've got lots of, more mundane, current conditions, lots of science. He goes, we're all grown-ups here. We need to see this. So, but I'd like to thank the Climate Reality Project for providing training. Al Gore set up this operation in 2007. That's when I left the shed. Oh yeah, that's good if we can keep the lights turned down a little bit more. And I've been back there annually getting additional training in Nashville and some other areas. And actually, they had me doing mentor work with other presenters. He's trained over 6,000 people worldwide. When I was in Chicago last year, there was 900 people attending from 70 countries. So it's a very broad organization. He's doing a whale of a job. So tonight we're going to talk about anthropogenic global warming. This is a term that's probably the most precise term. I don't like to use climate change. I think that's kind of a cop-out. So AGW, this is what we're trying to decide. Is this actually happening today, and are we seeing these effects? We're going to talk about the reality. The reality as the scientists see it. Everything you're going to hear me say today represents the current scientific consensus. 97 of the 100 climatologists studying in the field and publishing currently agree with what I'm going to say today. But how did I get here? I mean, what makes me come in front of groups like this and give you bad news? Much easier to show pictures from my vacation and sailing and lots of things, but I tend to have taken this task on. because what happened in St. John. This is my wife and I own a timeshare in St. John, and every year we come back and dive the same reefs. And as a diver, I'm fascinated. I was working with the animals at the shed, and there's those rare shots here. I'm usually taking the shots, but this was taken just moments before I was engulfed by that enormous sea monster. But usually it's me taking the pictures of the wonderful reef creatures that we see there, and I fed and nurtured at the shed aquarium. We obviously get some coral into the pictures here, but I started to realize as the years went on that our favorite reefs were turning white. And they were dying. And I needed to understand why, and I was told and figured out from reading that it was the heat of the oceans that had gone up just a couple of degrees and was actually demonstrating to me in human time scale what normally occurs over geologic time scales. And that's what's so different about the crisis we're in now. It is happening so rapidly. And I realize that all the animals I love to observe and study and talk about are all in danger because the corals are the most threatened ecosystem in the entire planet. Then this happened. In one fall, going into the next winter, 50% of the reefs on St. John were bleached and died. This is in a national monument. This was created as a national monument. Now, a lot of people never get underwater to see this. But let's use this analogy here. Say you went and brought your grandchildren to see these amazing national monuments, and a year later you came back and found 50% of them gone. That's what I experienced. And that scared me. The reason I'm up here is I'm scared. And I joined the Climate Project and resigned from the shed so I could spread the word more specifically on this topic. And that's why Don invited me here today, because we have noticed an increase in tropospheric, which is the area of the atmosphere we live in, of CO2 for decades now. Actually, when you go back and use proxy records, you can find the CO2 actually started a rapid ascent after being fairly stable just after World War II. And then now the instruments are coming into play now that we can actually measure this, and this curve is ominous. This is the amount of CO2 saturation in our atmosphere. This is steady as any in science. Now look at this look at the years here from the turn of the last century, and watch temperatures. They were cold and warm, but they kind of varied. There was a lot of, as you would expect, randomness in which areas of the world were hotter or colder. But then as you get after the 80s, you start to see that it's not going away, that they're way more above average temperatures than below average. And that's where we are today relative to this 1950, 1980 baseline. Now, statistically, you're a lot of retired business people here. Let's look at this. NASA took 100 individual window snapshots of environments all over the world, 100,000, I misspoke, individual climate snapshots, and created data for starting at this baseline. And this is colder than average temperatures, warmer than average temperatures, average temperatures. For each of these 100,000, put it in one massive database. And as you'd expect, for this decade, it was random. About as many cold as warm. But things started to change about 1980. And in this decade, there was a shift. Very few colder than average, way more hotter than average. Next decade, more shift. Again, very little colder than average. Again, way more warmer than average. And look where we are now. Almost 5 standard deviations away from this baseline. This is worldwide data, and this is what you're going to see today. It's not regional stuff, not cherry-pick stuff. We look at the entire world. So now we're having extreme weather events in many more areas of the world than we used to. And the temperature has been steadily going up since the last century. We're up about 1 degree Fahrenheit since the 1900s. And there's not just instruments that are telling this story to us. We can look at the ice, because the ice demonstrates what's going on in visual ways that are amazing. 1900, every shot you're going to see in this sequence is a glacier shot taken at one time and then many, many decades later from the same location at the same time of year. This is in Glacier National Park. Be sure to get your children to Glacier National Park where there's still glaciers there, because they are rapidly disappearing. This is evidence that you can't fake. This is evidence when the temperature goes above 32 degrees, the ice melts. That's all there is to it. From the Alps down to South America, Patagonia area, and look at this image I just captured the other day. Stunning. This is 1941. This is what's going on. But the people on the other side of this argument think that the 90 million tons a day of carbon pollution we're putting in the atmosphere has nothing to do with this problem. They know it just has to be something else. What could that be? We're going to explore a few of these things. I call them red herrings. You guys know what that means. It's something intended to divert attention from the real problem. And that's what's been thrown at you over the last 20 years. There's a lot of red.
It's called sunspots. Yes, solar activity. That explains why one sees similar temperature cycles on Mars and Jupiter to the cycles that are happening on this planet. That's why ice caps on those planets, like on ours, expand and contract. It's the sun, stupid.
That was Dana Rohrabacher in the halls of Congress. He's talking about the sun, of course, which is, over history and over the eons, been the major driver of climate variations, without a doubt. We've found since Galileo's time, when he started counting sunspots, that the sun radiance varies in about 11-year cycles. It goes up and down. And right now, we're coming up on one increase in this radiation. And the sun is always influenced. There's been times of very, very low radiation that lasted decades, and some high areas of radiation too that lasted many decades, and has been the driver of a lot of the climate that historically we know. But this amazing correlation started to fall apart about, again, 1980. And it's no longer a predictor of where our temperatures are going. So this is one of the red herrings, the first one I'll talk about. Solar activity, actually, since 1980 has actually diminished. Yet our temperature keeps going up. It's no longer the driving force of our climate anymore. The sun is actually 1,000 kilometers further away than it was from us 2,000 years ago. Solar forcings are negligible in the warming of the planet in the last 25 years. Sir Rohrabacher is not using the correct science. One climatologist put it this way, because he's getting frustrated with it. Keep on bringing it up. We keep having to knock it down because the data doesn't support it. And it's not just glaciers that are telling us this saga. Let's look up at the largest floating mass of ice in the world, and this is the North Pole and the Arctic. Again, it's a floating mass. It's not on land. This is the way it looked in September of 1984, much the way it has looked in this time of year in interglacial periods for the last 3 million years. This is what it looked like in 2012. We are losing the Arctic. And it's causing a lot of weather variations that we've experienced ourselves recently. But we're told that it's just temporary, that ice expands and contracts, and it's just a temporary problem. Well, it really isn't that simple, because what's going on in the Arctic is a reverse of the albedo effect. Usually, the sun over history has been able to bounce its radiation off the white ice out into space again. But as the colder or warmer ocean currents and air start to melt this the sun's rays end up penetrating the ocean, which is darker. Instead of reflecting, it's absorbing it. So it's starting a feedback loop. And we're creating a heat sink in the Arctic right now. And that's the area of the world that is changing the most, but nobody's up there to watch it, except things like submarines who have given us this recent data that is stunning. Then you add proxy data and try to go back 1,000 more years, you can see the decline has been extremely rapid over the recent millennia or two. And the instrument rating that's come in now confirms this. But we're not, every time there's a slight recovery in this, every time it gets a little colder winter, the people on the other side of this argument say, hey, it's recovered, it's recovered. And then it goes down and it comes back, oh, it's recovered again. So you hear, well, that was last year's story, this year it's recovered. But scientists look at the entire arc of data. They're not concerned with one point from another point. We look at all the evidence. And we also cannot confuse ice area with ice mass. It's altogether different. Now, a lot of people have seen sonograms, and this is a sonogram of a human heart. And I'm going to show you a little movie clip that takes off on this analogy here, because in our opinion, the Arctic is really the heart of this living planet. It is our air conditioning system. So there's varying areas of depth from over 5 meters to just seasonal 1 or less meters of ice. And like a heart, what happens is every spring the ice comes in, every winter it flows out, as you would expect. Now what I want you to do as I show you this clip, I want you to keep an eye on the red. This is the primordial ice. This is the ice that's been there for decades, if not centuries. Watch as we go through the years here, 1990, 1991, 92, what is happening to the primordial, the thick, the mass of the ice. So even if an airplane can say, well, there's a lot of ice out there, what we're finding out, it's very, very thin and probably will start melting entirely in the next decade. That's what it looked like before. So the mass of the ice up there is declining, not just the surface area. And that affects its ability to cool our climate. But they say, well, but there's a countering all this, there's way more ice, floating ice off of Antarctica. So we don't have to worry about that. I smell another red herring. Okay, let's look at Antarctica. Different situation. This is a continent. This ice is on land. It's not floating. And Antarctica is cold for 2 reasons. One, because it's on the South Pole. But second, because the ice is so high, 10,000 feet in most of the eastern half. So it's hot, it's cold because of its elevation as well. But this area over here is actually very low, some of it below sea level. Now, they're right. The ice, floating ice, has started to exceed the median a little bit more. So that's an accurate observation, but what does it mean? Well, it means that in their winter, the ice is just forming a little bit beyond what they've come to know as their average. But keep in mind, it only takes 15% ice to be considered sea ice. It's almost like a cocktail. And as the ice drops off the land of Antarctica, it goes in the ocean. And it becomes sea ice. So I really don't understand this argument at all, because this is what they're talking about. This is sea ice. And of course, as these calve, you would expect it to expand. But what we're learning now is that what's going on in this part of Antarctica is quite shocking and quite new information. The entire continent is warming a very small bit, but 90% of that warmth is occurring right here in this low area. And recently, some glaciers, you read this just the last couple of months, have started to melt in a perpetual cycle that is unreversible. Almost 200 feet of ice, or almost 200 feet of water would be created in our ocean levels if all of Antarctica melted. And the rate has increased of this ice loss by about 50%. And as I said, they have found some irreversible trends going on in this continent that will, without a doubt, within 50 to 200 years, or given a broad time scale, will raise ocean levels a little more than 3 feet. And this is the quote that's stuck in my brain. It's irreversible there. We've reached tipping points, and we're starting to go past them. And land-based ice is much more of a problem for us than floating ice, like in the Arctic. Why? Because land-based ice, or floating ice, is like this ice cube in a glass of water. When it melts, water level doesn't change. But you stack ice, like it is stacked on glaciers and on Antarctica, and it melts, it increases ocean levels worldwide. Greenland is the second largest source of ice in the world. And it, too, has seen a troubling trend of not creating as much ice in the winter as it loses in the summer. And there's one part of Greenland that's particularly troubling now because it is starting to melt in the northeast, and it hasn't been doing that before. And what's troubling here is what this area in the northeast connects to. They have discovered a vast underwater lake underneath Greenland. And once this northeast passage is free, this water can then flow out. Well, it's only a matter of time before we start draining this, because this is above sea level. And right now it already accounts for about 1/6 of our annual sea level rise. So we can't afford more coming from Greenland, because when ice melts and oceans expand, and the people have to move. They're driven out, migrations. They can cause a lot of cultural issues and socio-political and military and conflict. Now, the Antarctic ice sheet in the west, if the entire thing melted, it would add about 20 feet to our world's ocean, which is identical to what Greenland would do if it entirely melted. No, we're not going to say it's entirely melted. Let's say over the next 200 or 300 years, half of each of these belts. So we have a rise in oceans of about 20 feet. This is what would happen to Florida. I think Disney World survives. Not sure, though. But Miami is doomed. Miami is now doomed. And like the cultural issues I was talking about, what happens when all of these Floridians and their culture moves up to the old Dixie of the Old South to avoid the water? Old South is going to have to get used to shuffleboard and mahjong in blue plate specials. This will be a culture shock. But seriously, this prospect is not good to look at. This is what happened to San Francisco. This is in Manhattan, where we're have built a monument to tell us to be prepared in the World Trade Center for anything. Be wise. Don't ignore threats. This is what would happen to Lower Manhattan should ocean levels rise 20 feet. Now, Mr. Gore put this slide in his movie, and he was criticized about it because the people thought it was too extreme. He had a judge in England tell him, you got to temper that. People have to know that this may not happen in our lifetime or our children's lifetime. And he said, well, I never really did. I said, if this melts, this is what will happen. But what happened just a couple of years ago now, or a year or so ago, is depression of what we're talking about now. This is not alarmist. Shortly after this heat anomaly built up along our northeast coast, what happened? Remember? Remember what hit this area? Yeah, I hear it in the audience. Hurricane Sandy. It followed that heat right up the east coast and went further north than they usually do. It was Category 1. It wasn't a big deal hurricane. But this is what it did to the subway system. Now, I love scuba diving, but this is not what I had in mind. So it happened because we had a 2-foot increase in surge when that hurricane hit. And that's all it took.
When you look at a volcanic eruption, which I've seen scientists reveal that this could be 50,000 times what man's involvement in terms of creating CO2 would be, you begin to scratch your head and wonder, wait a minute, what is this?
Well, what is this? Is it volcanoes? Is this what's caused things like we've seen here? Well, I think this is another red herring. Because which emits more CO2? Volcanoes or humans? It's not even close on an average annual basis. 150 to 200 times more CO2 is emitted annually by humans. So it's not volcanoes. And some skeptics claim that all we do is rely on computer models. We don't have anything to back this up. But we have more than that. We have 12 separate lines of scientific evidence that show objectively to our eyes what is going on. It's an overwhelming scientific case. But if we prevail on this side of the argument, a lot of companies are going to have to leave a lot of the petroleum in the ground. That's already on their balance sheets. And there's a lot of money to prevent that because billions is at stake. And they know that they might not be able to extract all that. So they fund lavishly organizations to try to put a little bit of doubt into the conversation. So they try to blame things. How about a vast left-wing conspiracy among all these scientists of the world? After all, that herring swam in from the left. Is this possibly true? Well, think about this as a plot line for a movie. Okay? 97% of the world's scientists contrive an environmental crisis, but are exposed by a plunky band of billionaires and oil companies. Well, I suppose it could happen. But how do you get people that don't even speak the same language to cooperate and provide the same data? Any one of which, if they had the secret memo saying how we're collaborating here to fudge the data, if he would raise his hand, that climatologist would be the most famous climatologist in history and be rewarded amply. That doesn't happen. It isn't happening because it isn't a conspiracy. Scientists love to criticize each other. So then we go to ridicule. Seemingly run out of arguments. And they particularly like to say that CO2 isn't harmful, like Donna Rohrabacher said, that we're an idiot for thinking it's harmful. It's a human waste product is what it is. And we don't say it's irreversible.
This show has won so many science awards. Sometimes we get talking about highfalutin science, things like this, and people are like, what are you talking about? So let me just break it down. Carbon dioxide is basically this. Look how much pollution I just put out.
That's some pretty highfalutin science. Pretty intimidating.
George, the idea that carbon dioxide is a carcinogen that is harmful to our environment is almost comical.
I'm sure you saw the error in that. Yes, scary, because they're not dealing with reality. No, it's not a carcinogen. It's a human waste product. That's what it is. We can't live in a room full of CO2. All we say about CO2 is it creates heat. That's it. It's natural, but it does create heat. So then people like myself become discredited as climatists, as I was called in my debate opponent's book. Okay, I'll take that. I'm a climatist. I'm no problem with that. But then they do stuff like this, and this ticks me off. How can they do that? Well, these companies were so offended by this billboard that they all dropped out of supporting the Heartland Institute, except no coal, no oil or gas companies decided to leave. They still support it. And that's how the attack is. Let's deal with the science. Let's not kill the messenger. To deny what I'm saying today is to deny the physics of the greenhouse effect and the carbon cycle. It's been a while since we've been in 10th grade science, so I'm going to review this a little bit because I didn't understand it really well until I started working for the Climate Project. We have a carbon cycle here. That's a wonderful thing. We've got stores or sinks of carbon in the ocean, in plant life, in the atmosphere, and buried carbon underground. And geologically, what happens is the 3 of the 4 of these sinks exchange CO2 with other carbon sinks on a fairly equal basis. And this CO2 or carbon was never to see the light of day in the geologic plant. All right? If if this happens and there is no extraction of the buried carbon, the cycle is balanced. But then we discovered oil in 1859, and everything changed. And our national policy became one of extracting as much of this carbon from those old sinks and putting it in the atmosphere as fast as possible, because that helped develop us. We understand that it was innocent. They just developed, it's a marvelous fuel because it's portable. There's a lot of BTUs per pound, per gallon. But we've now gone too far, because now we understand what goes going on with the carbon cycle, because we've extracted millions of years of captured sunlight, put it in the atmosphere with no natural sink to absorb it. So now, what we have in the natural world, actually enough absorption to handle more than the emissions naturally. But with this man-made addition, we now have a deficit. Too much carbon in our atmosphere for nature to deal with. And this impacts the greenhouse effect. Quick primer on that. John Tyndall discovered this a long time ago and realized that certain gases, or vapors as they called it, retain heat in our atmosphere, and that's very good because we would be a cold rock in space without the greenhouse effect. He was right. Average temperature of the Earth is around 60 degrees. We'd be 63 degrees cooler if we had no greenhouse effect. And our civilization, if we had one, would be totally different, as you could imagine. So the greenhouse effect is important. It works to our advantage. We can't abuse it. And Savant Arrhenius, the father of physical chemistry, one of the first Nobel laureates, took his theory 50 years later and predicted that, if we put a lot of carbon in the atmosphere from industrialization, we might change the climate. And he figured we start to see heat in maybe 1,000 years. Well, he was a brilliant scientist, but a pretty lousy economist. He didn't realize how fast industrialization would spread all over the world. And what we're seeing now is the natural greenhouse gases that have been here for eons retain a very slight and a beneficial amount of heat. But as we add more CO2 and other greenhouse gases, we in effect thicken this blanket, and we retain an additional amount of heat that is dangerous to the civilization we've created. Anthropogenic global warming. We'll come back to that chart in a minute. How does this play out on a planetary scale? I'm sure someone asked. Earth and Venus are similar in size, have similar amounts of carbon. But as we discovered on Earth, we have this wonderful carbon cycle that circulates from the atmosphere to the oceans and the trees. And so in Venus, there is no life, is no carbon cycle. So all the carbon that was in its atmosphere since creation is still there. Now, what do we see in temperatures? Well, that balmy 59 degrees average for the globe. 855 degrees is the average temperature in Venus. Now, smart people in the audience say, Kent, it's closer to the sun. Well, then, explain Mercury. Half the temperature of Venus. Venus has a runaway greenhouse effect. It just shows the power of a greenhouse effect. We're not worried about going up 100 degrees. That's not going to happen here. We're worried about 5 or 6 or 7 degrees. And we couldn't measure the amount of CO2 in our atmosphere because it's such a small amount, precisely until the 50s, when these two gentlemen combined and started to measure CO2 in the atmosphere to test Arrhenius' theory. And again, this is the chart I showed you earlier. Steady increase every single year, like clockwork. There's such an important diagram that it is now mounted on the wall of Scripps Oceanographic Institute, known as the Keeling curve. Most important graph, one of the most important graphs in history. And what we're finding out is, yes, as the temperature goes up compared to the 20th century average, what's also going up? CO2. They're going together. Arrhenius was right. Okay, but I got to cover this. What about that cold winter we just had? Doesn't this pop that balloon quite a bit, Kent? Well, one chart explains it. One slide. Look at the globe. Look at the world at that time for these above average, warmer than average, and record cold. Look, the only place in the world that was experiencing what we did last year was us here in the Midwest. California had its warmest summer on record. So did Alaska. It's very regional. We're worried about an increase in temperature between 3 and 10 degrees. This is what we're worried about. Doesn't take much. But many skeptics say it stopped. Hey, it's leveled off. It's no longer a problem. But it really doesn't matter. If you look at any of the 4 groups that measure worldwide temperatures, you'll see that only one, the Met Office, got that high in 1998. The same one they criticized, and by the way, in the email fiasco of a couple of years ago. So, has it really leveled out? You smell another fish here? Because only if you cherry pick the data. Again, we'll look at the same chart. And let's look at 1 year, 1998. We had a hot El Nino. We had the sun radiation at a very high level. It was an anomalous year, the warmest year in the thermometer record. But you notice they always start with 1998. If you look at that, yeah, it's kind of leveled off from the Met Office data. But if you watch when they say it, they'll always make sure that 1998 is the year that they start with to give us that conclusion. You can cherry pick data by picking any points at random and prove any case you want. It's the entire scope, the entire average over decades that matters and what's important to scientists. You can't cherry pick the data and have scientific relevance. All the history tells us that you add CO2 to the atmosphere and other greenhouse gases, the temperature goes up. It's proved in science courses in high schools every single day. It's basic physical chemistry. Now, if I haven't convinced you that we're warming up, I think I want to give you some evidence the fashion industry has gotten way ahead of this curve and figured it out a long time before most of us have. Oh, marketing people, they know what they're doing. But there has been not quite as much heat as some of the calculations predicted recently on land, and that's because the oceans have been our savior. They've absorbed more heat than was expected. Here's the way where this excess heat has been going, attacking those corals that I love, and the fish that I love. And on land it's gone up, but nowhere near as much as the ocean. And the ocean will eventually give up this heat. That's physics. So the skeptics think all of the heat goes in the atmosphere. And reality is teaching us, and science is teaching us, no, it's actually going into the ocean and soon will be released in the atmosphere. Ocean temperatures are going up, which is what I learned in the early 90s. And of course, thermal expansion. As oceans warm, they expand, and so they're rising. And the amount of increase has doubled in the last 2 decades. So this is an ominous trend. So water heats, it expands. Add that, and then we're not even talking about the ice. But what about before the instrument record? All my data so far has been since the development of the thermometer. Well, to do that, understand where we are geologically, we have to use ice core samples where we can release frozen bubbles of air and analyze both the temperature, believe it or not, and the amount of CO2 in the atmosphere. And we've seen that we do these ice cores. This is one sample out of Antarctica over 400,000 years. And we have data that goes back 800,000 years, shows exactly the same thing. We've had a correspondence of CO2 to temperature all along. Sometimes the CO2 precedes increased temperature. Sometimes the CO2 follows it. It doesn't matter. It's like bread and butter, bread and crust. They always go together. You can't separate them. Where we are today, higher than we've been in the last close to 1 million years in saturation of CO2 in our environment. And if we fail to act, the UN says that we're going up to 1,000. We have to do something to prevent this, because it is theoretically possible to fill our atmosphere with greenhouse gases. It's only 6 miles deep, the troposphere in which we live. It's a finite area of atmosphere. And it's the only part of it that's livable. And we're putting in 90 million tons a day into this atmosphere and think, well, it's nothing, we don't have to worry about it. There will be no changes. Well, let's look at this again. Let's compare where we are to the average, that data. Then let's add the two variables. Temperature, which we've already seen, how that follows CO2, just like your physics teacher would have told you. And then let's add a third, ocean levels, which also follow the same cycle. They're just another fluid. Atmosphere is a fluid to an engineer. So is the water. And if we keep going up, this correlation is going to mean that as we exceed 400 parts per million of CO2, it's going to happen as the temperature, as well as ocean levels, will rise, as they always have in geologic history. But aren't there other forcing mechanisms besides this greenhouse effect? And yet, you're right, there are. Historically, there have been volcanoes, which John Boehner mentioned, but volcanoes actually serve to cool the temperature, not increase it, because they put a lot of particulate matter up in the stratosphere that acts like a little bit of shade. And so El Niños and La Niñas, they affect climate all over the world. El Niños raise the heat, La Niñas cool it. So James Hansen of NASA put together this recent chart from 1950 to show the effects of major volcanic eruptions and chart them against the El Nino and La Nina cycles. You can see volcanoes tend to lower the temperature, and La Ninas tend to lower the temperature if you look at the correlation, and El Nino's the opposite. But the trend keeps going up. So the lows are higher as well as the highs are higher. Yes, they affect the climate, but they're not overriding the effect of the greenhouse effect, because this increased CO2 is the largest contributor to what we're seeing today in global temperatures. So has our greenhouse effect gone into overdrive? Yes, it has. Is it our fault? Well, that's what I'd like to discuss in the last half of this presentation, because this is not a coincidence. There are distinct human fingerprints on this. We are all over this. The most obvious, we put in tons of CO2 carbon into the atmosphere. That has to have an effect. That's what we have done. And it's come from mostly the burning of fossil fuels, but also the way we use land, removing trees, more livestock farming, etc. And these greenhouse gases come from all aspects of our civilized life, things we take for granted, our transportation, our factories, our homes, and things like forest fires add to it, and fertilization. What we call civilization is adding to this problem. Another fingerprint is that nighttime temperatures are breaking more records than daytime. Because of the greenhouse effect, when the global turns away from the sun, you still stay relatively warm, unlike other planets. There have been heat records like crazy in 2012, tied and broken during the day. But at night, they're even more broken, which is a sign that the greenhouse effect itself is causing this, not the sun, not volcanoes. Because we'd expect the opposite effect. It was a sun and volcanoes, because in the nighttime, it'll always be cooler. Another powerful argument about our effects on this climate is oxygen depletion. Okay, when you burn a fuel, you consume the fuel and oxygen, right? So you would expect that we're burning all this fossil fuel and consuming oxygen, you'd see a decline in the oxygen level in the atmosphere. Are we seeing it? Yes, we are. Again, Charles Keeling showed very slight diminishment, but steady in correlation with the increase in CO2 of the oxygen in our atmosphere. This is not a threat to any plant or animal for eons. It's just a perceptible measurement that confirms our theory. And let's look at the stratosphere. Look at this picture again. This is the stratosphere. This is the troposphere in which we live. Now, it is obviously affected by the sun, as you'd expect. And if it was the sun doing it, all levels of atmosphere would be heating in harmony. But it is not actually what's happening. Because the same effect I talked about, where we are capturing this extra bit of solar radiation, it's preventing it from going into the stratosphere, where it would slightly heat that up too. As a result, the troposphere is heating, the stratosphere is actually cooling because none of these greenhouse gases are getting up there, or very much less than historically is more accurate for me to say. So have we supercharged this greenhouse effect? In my opinion, yes. And from direct spectral evidence from NASA, confirms that since 1970 to 2006, they have seen an increase in the effects normally associated with the greenhouse theory. In order for us to believe that it's not what I am discussing, we have to put in our mind two things. That first, something unknown is suppressing the natural greenhouse effect because we're putting all this carbon in it and supposedly it's not responsible. So something must be suppressing the greenhouse effect, as well as something unknown creating this heat, and also something unknown creating this increase in CO2. So to accept the other side of this argument, you have to accept two unknowns. And my brain just doesn't allow me to do that. It's just reality keeps busting in and saying, no. The truth that we are talking, and I am going to say the word truth, is attacked, as it always has been attacked when it's new, it's different, it's challenging. They often claim there's no scientific consensus. You hear this all the time, and as like I said earlier, 97% of climatologists in the field agree with me. In published peer-reviewed articles, less than a fifth of 1% disagree on this topic. Every major National Academy of Science in all of these nations agree with what I say. Every single one. And this is what they say. The action is urgent. Need for action is urgent. It is indisputable. The amount of academies that reject what I'm saying? None. So, and you add to this all of these groups and organizations involved in the study of atmospherics and physics. All of these professional societies also agree with what I'm saying tonight. So these organizations have my back. And that's why I'm very confident when I'm up here talking to you about this. But who has the other side's back? Who's backing the other side of this argument? You need to ask that question. But I think we know. It's logical. Companies like this protecting their bottom line and their shareholders' interest. We understand that. But it still didn't prevent this CEO from making one of the dumbest comments of the century so far. Because they don't get it. But actually a more ominous quote from the same gentleman is this. He's describing you as the illiterate public that needs to be helped to understand that we can just manage these risks. He's talking about you. And me, of course. And we've seen this sort of thing before. All these red herrings I've been discussing are a strategy that's put in place by large carbon polluters with a lot of money almost 20 years ago. A secret memo shown to the press about 6 years ago now revealed this quote. They want to reposition global warming as a theory rather than as a fact, just to create doubt. All you have to do is a little doubt that you don't act. But we have seen this act before. Have we? Remember similar things, such as some of the same people, Fred Singer, are doing this, that worked with the same ad companies, taking the tobacco companies' product placement.
Cigarette, doctor? Thanks, doctor.
Terrific. What a strategy. Now, the latest thing is trying to say, hey, we can clean up coal. Coal is the by far the largest emanator per BTU of greenhouse gases. So they have to figure out a way to make it appear clean. And this campaign has been going on forever, from the 20s through the current day. Clean coal, we can do it. Clean coal is a myth. We can't, it has not been able to be developed in the 60, 70 years. But they still, now they're just updating it, trying to make it look cool. Hip, man. Cool's cool. I don't know. There's a certain familiarity to that. Oh yeah, it is cool. Well, now is not the time for clean coal because it's a myth. There's much easier, less expensive things to do, and we have to think out of the box. We cannot think in the same way we always have about this problem. We need to approach it from a different method. We have to realize that the environment doesn't need us, or historically has not needed the human race. We're just a parasite, really, because we don't contribute much back to it. Which species on the planet is more valuable to the natural world? E. coli bacteria or Homo sapiens? Think about it. That's a tough ego blast, isn't it? But actually, this dynamic is changing because the environment now needs us. The worm has turned. It needs us to reverse what we've done. We have an enormous responsibility now. Because let's forget about polar bears and all the other animals that are affected. Let's just look at human civilization because we're starting to get beyond where we've been successful as a society. When we got off of the African plains, and temperatures started to moderate after the last ice age, they stayed in a very comfortable range. And our entire history was spent in this comfortable range, sometimes getting a little warmer, sometimes a little cooler. And here we are today. Now, each of these periods here were due to natural forces and wobble of the Earth, orbit, eccentricities. But there's always a correcting. Nature has a way of correcting things. But here, this is us. There's no way to for nature to correct it. We have to. This is different than all the other warming events in history. Because right now, we're comparing ourselves to great extinctions throughout geologic time. The late Permian, which is actually, some say 90% of species were killed, was due now, they realized, to the melting of the Arctic tundra in Siberia due to volcanic activity. Superheated the planet too fast for animals to adapt. Well, here we are today. We're in the Holocene. That's the epoch we're now in. And we're already seeing a decline in species similar to what we've seen before. And if there's a paleontologist that is alive 100 million years from now and looks at our data and what is going on, the label we're going to have here is the Anthropocene extinction. In other words, the human-caused extinction. We got to remember, we're only borrow this planet. We don't own it. We pass it on. And we have a responsibility to pass it on in a better condition than we got it. So the time for action is right now. It's happening. It's real. It's scientifically observable and provable. Because right now we're conducting a massive chemistry experiment with our atmosphere, hoping that in spite of our changing these dynamics in the atmosphere, that in the crap table of life, we're going to just roll some 1 and 2 degree temperature changes and just keep rolling and hope that the odds are with us. But unfortunately, the scientists are now telling us it's like we're loading the dice. So as we roll, the odds of rolling higher temperatures are increasing. And it's almost like they're adding more dots to the dice. So it's possible to roll not just 12s, but 13s and 14s. This is the gamble we're taking. So are you feeling lucky? Are we going to be lucky? Or are you going to listen to the science? It's like gambling. You do some standard risk analysis if you can gamble and stay under control. As you do in all things of life. Look in the refrigerator. Oh, this kielbasa's been in there for 2 weeks, but oh man, do I want it. What's the worst that could happen? We do this all the time. Unconsciously, we're always analyzing risk and making decisions. But it also goes on in larger scale in corporate boardrooms all over the country. Risk analysis is a huge discipline in business. And let's do some risk analysis very simply for what I'm describing today. All right, anthropogenic global warming. It's not happening, or it is happening as I believe. We take actions, such as getting off of fossil fuels. We do them, or we don't. Let's fill in the boxes. I'm wrong, we take actions. We spend a lot of money. My God, maybe we spend so much that we go into another global recession. Well, we've been through one. We know what that's like. It's tough. It's not the end of the world. Now let's say I'm wrong, and we take no actions, like the other side of this argument says. We made the right decision. Okay, now let's fill the other box. I am right, and we take actions. Okay, we got those same costs. Hey, but we saved the world. That's a good outcome. Let's say I am right, and we take no actions. We have climate catastrophes that affect all aspects of society. Geopolitical, economic, social, public health, environmental, agriculture, all affected adversely. But then let's look back at this other box we thought was so bad. We spend that money, but actually we're left with an infrastructure. We've spent it, we've created new jobs, we've created clean energy, we've cleaned up our air and water. That's not a bad outcome either. So it's time we start figuring out which box we are in. Which box do you want to be in? In my opinion, we need to stop arguing about the columns and need to start planning and arguing about the rows. Which actions do we take and which do we not? Which is a smart action, which is the most efficient, which is not? The true-false argument has to evaporate because it stops us from doing anything. It keeps our heads stuck firmly in the sand. And we can't be that way with future generations at stake because there may be an Earth where this reality doesn't matter. But it isn't this one. Because on this one, this is the only Earth we will ever have to love, to touch, to tend for our children and their children. And that's simple truth. Is the reality we're dealing with today. And I thank you very much for your attention.